Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Power distribution. In this module, we are going to study about the introduction, bus bar and its uses. Introduction. In order for the power available at the appropriate generating sources to be made available at all inputs of the power consuming equipment and systems, then clearly some organized form of distribution throughout an aircraft is essential. The precise manner in which this is arranged is governed principally by the type of aircraft and its electrical system, number of consumers and iodation of consumer components. For example, in a small light aircraft, electrical power requirements may be limited to a few consumer services and components situated within a small area, and the power may be distributed via only a few yards of cable, some terminal block, circuit breaker or fuses. In a large multi-jet transport aircraft, on the other hand, literally miles of cables are involved, together with the multiple load distribution bars, protection networks, junction box and the control panels. The bus bars. In most types of aircraft, the output from generating sources is coupled to one or more low impedance conductor referred to as bus bars. These are usually situated in junction box or distribution panels located at central points within the aircraft, and they provide a convenient means for connecting positive supplies to the various consumer circuits. In other words, they perform a carry-all function. The function of a distribution system is primarily a simple one, but it is complicated by having to meet additional requirements which concern a power source or a power consumer system operating either separately or collectively under abnormal conditions. The requirements of abnormal conditions may be considered in a relation to three main areas, which may be summarized as follows. Power consuming equipment must not be deprived of the power in the event of power source failure unless the total power demand exceeds the available supply. Faults on the distribution system, example the fault currents, grounding or earthing at a bus bar, should have minimum effect on the system functioning and should constitute minimum possible fire risk. Power consuming equipment faults must not endanger the power supply to other equipment. Vital services. These are those which would be required after an emergency wheels up landing, example emergency lightning and crash switch operation of fire extinguishers. These services are connected directly to the battery. Essential services. These are those required to ensure safe flight in an in-flight emergency situation. They are connected to the DC and AC bus bars as appropriate and in such a way that they can always be supplied from a generator or from the batteries. Non-essential services. These are those which can be isolated in an in-flight emergency for load shedding purposes and are connected to AC and DC bus bar as appropriate, supplied from a generator. Another example of a split bus bar system based on that used in B737 primary power source is non-paralleled 11-5 200 volt 3-phase AC from two 40 kV A generators. A source of AC power can be supplied from another 40 kV A generator given by an auxiliary power unit and also from an external power unit. Direct current is supplied via 3 TRUs. The four power sources are connected to the bus bars by 6 3-phase breakers and 2 transfer relays which are energized and de-energized according to the switching selections made on the system control panel. An interlocking circuit system between breakers and switches is also provided to enable proper sequencing of a breaker and overall system operation. A source of power switched on to the entering the system always takes priority, and so will the automatically disconnect any existing power source. The switches are of the momentary select type. In the following a selection, they are returned to a neutral position by spring loading. The bus transfer switch is retained in the auto position by a guard cover to provide a path for signals controlling the normal and alternate positions of the transfer relays. In the position off, the transfer relays are prevented from being energized to the alternate position so that the two main generating systems are completely isolated from each other. The indicating lights on the control panel are illuminated as follows: ground power available blue, transfer bus off amber, bus off amber, gen bus off blue, APU gen bus off blue.